All right, so here are the answers for the Chapter 2 Formative Assessment that we did not get to in class. All right, so here's the deal. We've got this graph over here. Let me do this. Oops. Oh man, F minus. All right, there we go. So we've got this graph over here. The first thing to notice is that this is in fact a velocity time graph. Okay, so the first question says, during what time intervals is the object moving forward? All right. The common mistake I get people saying is they look at this graph and they go, oh, look, it's sloped uphill. That means it's always moving forward. And that's not correct. Okay. If this had been a position time graph, that would be correct, because then your position would be increasing, which would mean that you're moving forward. All right. But that's not what's happening here. It's a velocity time graph. So the question that you need to ask yourself is, what does moving forward have to do with velocity? Okay, and the idea is this: if you've got two cars that are moving at 10 miles an hour, if you've got one car going this way at 10 miles an hour and one car going this way at 10 miles an hour, then they both have the same speed, but this one has a positive velocity and this one has a negative velocity. So moving forward is the exact same as saying positive velocity. All right, moving forward means your velocity has to be positive. So what this question is really asking you, during what time intervals is the object moving forward? It's really asking you, during what time intervals is the velocity positive? So the idea then is that if this is a velocity of 0, then anything down here would be a negative velocity, and therefore it's moving backwards, and anything over here is a positive velocity, and therefore is moving forwards. So when is the velocity positive? When is the object moving forwards? Would be after 4 seconds. Okay, or you could say from 4 to 6 seconds, or 4 to 8 seconds, or however you read the graph. But what's important is it's after this point right here, the velocity is positive. Okay, so that is part A. All right, part B, when is the velocity increasing? Well, the idea is the velocity starts at negative something, and then it increases up to 0, and then it continues increasing. Since the graph is always sloped uphill, the velocity is always increasing. So it's always increasing. That's it. Okay? Now, my guess is some of you got this wrong and put the answer for C here. So C doesn't ask you when is the velocity increasing. C asks you when is the speed increasing. So what you need to remember about speed is that the smallest speed you can possibly have is 0. Okay? So what's actually happening here is, at this point, even though your velocity is negative, remember, you can't have a negative velocity. Ah, crap. I just recorded that. Don't show this to your parents. Try again. Remember, your speed cannot be negative. So if my velocity here is, for example, whatever, negative 30 meters per second, then my speed is actually positive 30 meters a second. So from here to here, my speed is going from 30 to 0. So that's actually a decreasing speed, right? Remember, what we said in class was if your velocity is getting closer to 0, then that's a decreasing speed. That's what's happening here. Our velocity is getting closer to 0, decreasing speed. Where the speed is increasing is here, because my velocity is going from 0 to some other bigger number. So when is the speed increasing is, again, after 4 seconds. Okay? I apologize for my foul language. All right. And then finally, the last question says, give an example of an object that might have a velocity time graph that looks like this. So what we need to do is we need to have an object that is moving backwards and slowing down, and then moving forwards and speeding up. So, maybe it's a car that is going backwards, slowing down, stopping, and then going forwards faster and faster and faster. Maybe it's, a frisbee that you've thrown this way into the wind, and the wind slows it down and then pushes it back this way. Maybe it's, that's pretty much what's going on. All right, so I keep wanting to say, are there any questions? That wouldn't work because this is a video. So if you got questions, I'm around before and after school. Come in, talk to me. All right, next question. Look at the time, look at the graph at the right. What's the object's displacement between 4 and 10 seconds? If you got an answer of negative 120, then you made the mistake of thinking this was a position time graph. A lot of times people do that. They go, oh, well, I'm just going from 100 to negative 20, so that's negative 120. That would be the displacement if this was a position time graph. But it's not a position time graph, it is a velocity time graph. So here's what the graph is telling us. This point right here, right, between 4 seconds, so here's 4 seconds. So after 4 seconds, my velocity is 100 meters a second. That's my initial velocity. Okay? Then, after 10 seconds, my velocity is negative 20. That's my final velocity. Okay? All of that takes 6 seconds, right? The time from 4 to 10. Okay? So, in order to find our displacement, we've got two choices, but regardless, whether I use this or, oh, well, to be honest, that's probably the easiest way to do it. That said, I know most of you guys are using this equation to find displacement when you're accelerating. So if you're doing this, then awesome. I think that's the easiest way to do it. Find your average velocity and then multiply by your time. But like I said, I think most of you guys are using this equation. So to use this equation, we got to find our acceleration. So our VF is negative 20. Our VI is 100. Time is 6 seconds. Plug that into your calculator and you get negative 20 meters per second squared for your acceleration. And then you can plug it in here to find your displacement. So you get half of negative 20 meters a second squared times 6 seconds. Don't forget to square it. Initial velocity is 100 meters a second. Time is 6 seconds. Plug it into your calculator and you get 240 meters. There you go. Cool. All right, and then number 3, although it is a very good question, will not be on your test. So I'm going to not worry about it. All right, I hope this was helpful. If it was helpful, let me know. I'm thinking about starting to record answers like this a little bit more often. So, and hopefully a little bit more carefully. I did this one pretty quickly. But cool. I'm around before and after school if you have questions. I will see you tomorrow.